all right. You made it. The final conference of the day. So, I promise this. I'm gonna make this very quick because I'm very thirsty. So, and I can see some of you as well. So, let's talk about, first of all, I was prepared a hands-on training, but thanks to the Turkish customs at the airport, they took some spare parts that I have it with me. So they say to me, you choose. You can go to the city or you can stay here with your parts. So here I am. So I will talk about bearings, and at the end, you will need your cell phone because there is a quiz, okay? So you may want to take very close your cell phone with you. Let's talk about bearings. Of course, this is the Bearing and Power Transmission Forum. But first, I can see you all sitting there, working and selling and consulting about bearings. But I will tell you this thing. We are all in the reliability business, okay? Whether if you are selling bearings, if you are selling greases, if you are selling power transmission components, we are in the reliability business. So let's take a look about reliability. First of all, we have two oil companies here, very big ones. In one side we have Chevron, and in the other we have BP. So let's go back in time to the early 2000s, okay? You can see how the stock exchange behaved. So as you can see, they were in the ground. The value of their stocks was very cheap, very low, okay? So as long when the years were passing through, they have some accidents. First, in a refinery, Texas City, okay? A big explosion, killing many people, injuring hundreds of them. And they didn't learn that lesson on that day. This company, they were talking about being profitable, earning money. They don't care too much about environmental issues, okay? So their only concern was in making money. Some years later, we had Prudhoe Bay incident, okay? This was the breaking point. This was when the oil company started to care about environmental issues. You know, they start to work together with these like organizations like Greenpeace and such. They start to make a speech saying that they care about the world, about the care of the planet, and everything. But only one company did that. The other one still want to make money. And again, some years later, 2010, they have the Deepwater Horizon oil rig catastrophe. I believe there is a movie, you can find it on Netflix, right? So they have this big explosion because some water pumps doesn't perform well on that day. So this was also another breaking point. So this company start to talk about reliability. How in maintenance we can make our machinery reliable. Okay? And as you can see, the stock market went up for one company. The other one stay on the ground. They start to lose money, to lose value. And you know, when we have this kind of accidents, the investors that get afraid and they pull out of their money and put it in some other's pocket. Okay, so I'm going to talk about cultural transformation because we need, in order to have reliable machinery, we need to have reliable people. Okay? That's the combination. That's the winning combination. If you have only reliable machine and your people is keeping outside the loop, you won't achieve your objectives. But if you have reliable people working on your machinery, you will find it reliable machinery. It's going to, at the end, is the winner combination. So, of course, we have the journey to world-class maintenance. Some companies, they prefer to stay here. Some companies, they prefer to stay there. There is a long way. We need to work with procedures. We need to work with training. We need to work with people. In this part of my conference, I will speak about precision maintenance, okay? Which is one of the most important techniques you can do on the floor. Think about this. We have this new installation, okay? We are building a new plant. We are installing machinery. And most of the times, maintenance staff that is going to be in charge of that machine, they are not to be allowed or they are not involved in this process of installing machinery. Some months later, years later, the machine will fail, and not because some operation, not because the people, but because the installation for itself. You will have case distortion, you will have seal failures, bearing failures, whatever you want. And the maintenance guys, they don't know that because they didn't get involved in the commissioning part. Okay? So, this is very, very important. I was telling you that we need a cultural transformation. So, every time that I go to a plant, it's always the same. People is telling me, oh, Alejandro, I know we are mounting the bearing with a hammer and a chisel. I know that. But that has been doing the same for years. Nothing is going to change. Our managers is telling us that put grease in the machine until we see the new one coming out from the electric motor, for instance. That's the custom here. That's the traditional way to do the things here. But we need to make this cultural transformation in order to go to one plant and people tell us, okay, we are performing the job using the right technique, we have trained people, we are using state-of-the-art technology. That's the combination we are looking for, the cultural transformation we are looking for. Now, it's very common to have machinery that are shaking, noisy, hot, and dirty. We don't like that. We don't need that. We are losing money. One of the main problems of the engineers, I'm an engineer, and one of the main problems is that we don't talk money language. It's very difficult to talk with the financial guys. So if you are a condition monitoring guy, you always like your boss or your manager to go to your desk and say to you, well done, my friend, you are doing a good job. That never is going to happen. Because maintenance, we were told that we only need this department when things goes wrong. Okay? So in this cultural transformation, in this movement, now we have the optimal states of reference with our machines. We like to run in smooth, quiet, cool, and clean. And the main responsible to doing that is the human. Don't forget about the human. It's the most important asset of a company. So, precision techniques. The first one, misalignment. So think about this. Under normal loads, the lubricant provides adequate film separation. Okay? Is what we like to have. But if we have a misaligned machinery, we'll increase vibration and increase load. Okay? And the loop film strain is overwhelmed, which causes friction, wear, failure, everything that we already heard in this day. And the most important is misalignment equipment reduce film strength, producing surface-to-surface contact, fatigue, and wear. Who wants to tell me if the lubricant that we are using is responsible for this problem? It's not. Simple, it's not. And in maintenance, when the staff call by radio and say, oh, this electrical motor is heating up or rising in temperature, our first response is adding grease. Because we think that will solve the problem. We want to resolve all kinds of problems by adding lubricant to our machinery. And in fact, we are killing it. Yeah. If we are misalignment machinery, we will increase by 20, 25% over 100 the loads that are acting on the bearings, and we will kill the bearings because of that. Jarvis in the morning says that who is responsible for killing bearings? Jarvis? Humans. Because they don't know how to use dial indicators and laser alignment systems. They trust on their eyes. They put some small ruler to make the alignment, small thread to perform that job. And then some of them, they will blame the bearing because of this. A lot of students that I had, they say to me, Alejandro, I don't know why, but my machine only works with this specific brand of bearings. Okay, let's go to the shop. Take out the bearing. I say, oh, this is your specific type of bearing, your brand of bearing. Oh, yes, it is. And the technician starts to analyzing the bearing, and I say, okay, I know what's the problem. You see, this is the correct brand, but it says made in Mexico. And the bearing must say made in Germany or Sweden or something like that. Because they don't know about bearings. They don't know, just don't know. And that is because some of them still are thinking that bearing is a commodity, that we don't have to know more about them, just installing and replacing and proving one mark or another brand, etc., etc., etc. Yeah? So, the main function of a bearing is transmitting loads. Everything that is happening in my machine, the bearings will speak to me. Okay? The good things and the bad things. So I need to hear my machines. Whatever your maintenance strategy is, I mean, if you have a very low maintenance strategy, that means hearing your machinery, touching your machinery, of course it's an inspection, but you will not have time to act in a correct way. If we're going up in the level of inspection using condition monitoring equipment like vibration, ultrasound, thermograph, etc., 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 we're going to gain time. And in plants, time is gold. We need to act. We need to have time to react. We need to decrease the severity of the problem, right? So, just a little information. Every year, 10,000 millions of bearings are manufactured around the world. 10,000 millions of bearings. And in the plants, we were telling for so many years that the best maintenance we can do is preventive maintenance. So, what that means? That means that right now, almost 1,000 million of bearings are being replaced by preventive tasks. And you know what is the worst part of that? That some of these companies has another office that says condition monitoring. So we are investing in human resources, we are investing, or they are investing in technology, buying ultrasound equipment, buying vibration analysis equipment, and the condition monitoring guy is delivering one report every month, 12 reports by the end of the year, saying that, oh, the bearings on your electric motor are good, are okay, but someone is taking out this electrical motor to maintenance. We are losing money. We are losing money. If you can see this in another point of view, what about the environmental issues? We are destroying the planet because it's not only 1,000 million of bearings that can still run. It's also lubricants, it's also waste disposal, and in so many countries, we still rely on petroleum to generate energy, or lubricants, or whatever. So we are killing the planet. And we need to take this in account. No matter if you are in your 20s, in your 40s, or in my 50s, we are killing the planet. So we need to think that there is a way to make maintenance, to make green maintenance, good activities in order to take care of our only home that we have, our planet, okay? So, there is a report, a paper, a white paper. It came out a few years ago. It was written by the International Energy Agency. And in this report says that electric motor devices, driving systems, between 75 HP up to 350 electric medium motors, okay? They are accountable for 43 up to 46% of all global electricity consumption. This is a huge data, a huge one. When I go to see a customer and he says to me, hey Alejandro, the director, the principal, the CEO is asking me for savings, where I can get it? Do I need to buy online sensors? Do I need to buy, to use artificial intelligence? Where? So, I say to these people, come on, walk with me to the plant, but walk with me to the plant. I don't want you to stay in your desk, drinking coffee and in a very cool room. Come on, let's go to your plant. Let's go to your shop, and you will see your people, your technicians, using a hammer and a chisel, installing your bearings. Okay, I already know that. But I don't care about that because it's cheaper for us to replace the bearing. They have that mentality, that if they replace the bearing, it's cheaper rather to train a people, to train the guys. So, If you want to offer savings to one plant, take a look for your electric motors. It's the first thing that you need to do. Of course, you will have another kinds of machines, but that you will find the most savings you can get. And again, with the mentality, the people, and you already know this, the cost of a bearing doesn't compare to the effect of the failure, to stop a plant. Okay? We all know, have this knowledge. And some of us, we are repeating that speech to our customer. Oh, your bearing is very cheap compared to the effect that you will have. That's why I offer you this solution and that solution and everything. But do we really know about what we are talking about? Or this only one speech that heard in some other companies or some other colleagues, and we are repeating that? Because we need to believe in that in order to achieve it. All right? So, very small wisdom pills that you can take for this presentation. The life cycle of a bearing starts when they leave the warehouse of the manufacturer. Please, serve me my food in the floor of the bearing manufacturer. I will eat it from there. It's very clean. No dust, no vibration, with a very good temperature. But unfortunately, in a plant, they will not buy the bearings directly from the OEM. They have to buy the bearings through the bearing distributors. And come on, sometimes the bearing distributors, they are a mess. They have the main warehouse, and they have satellite or small warehouse closest to the factories, to the plants, because they want to attend the problem in a very urgent way. And because of that, in a very small surface, they not only have bearings, they have gears, they have couplings, they have belts. So think of this, think about this. Medicine has an expiration date. Food has an expiration date. So the bearings. How many of you have been in a plant that they have a critical component warehouse? And when you go to this critical components warehouse, oh my God, what a waste of money. What a waste of money. Very hot, very dusty, with vibration, and it's the critical component area. Some of them have air conditioning, some of them, not all. So, first, we need to take care about our warehouse. Because it's possible that I have a brand new bearing on its package, and this bearing has already a failure. And there will start blaming to whatever is in your company. For instance, I am a mechanical guy, and I am a believer that the electrician is the responsible for all the failures. If I am an electrician, I will say that the mechanical guy is responsible. And if the mechanical and the electrician are friends, they will blame to the condition monitoring guy. Because we were told that the condition monitoring guy has a magic ball, and he will tell me the day and the hour and the shift that my machine will fail. You see? And it's not like that. It's not like that. Because the lack of training. Right? Let me go back. Yeah. Another one there. What about the exclusion of contaminants? It's easy and cheaper to avoid your contaminants enter to your machine than taking out of your machinery. But we need training. We need culture. Mohammed, he was talking about the contamination, and of course, when we go to a plant, like a cement plant or paper mill, all the maintenance guys will say to you, oh, you know, we cannot achieve a long duration of our bearings because our process is very contaminated. They always like to blame their process. You go to a mining, to a cement plant, they will tell you, okay, we know that the bearing was long for 7 years in my electrical motor, but we cannot achieve that duration because of process. Oh, come on. And when you inspect the bearings, you will not find contaminants from the process. You will find contaminants from your shop. The guy, the human, is contaminating the grease, the oil. We still have, this is my machine, and in so many plants, they still have, you know, the Coca-Cola bottle to lubricate the machine. In some plants, they have the grease guy, and he's pumping grease. We don't care about to develop skills of the human being. So we hire this guy, and in the interview, human resources, we help. Hey, do you have any experience lubricating electrical motors? Oh, yes, I have it. Okay, you're hired. And then this guy goes to the machine and says, okay, I learned years ago that we need to put 20 pumps on the machine. Or another guy says, oh, I learned in other job that I need to add grease until I see the new one coming out. And that's the lubrication guy, not a technician, a lubrication guy. I don't care, because this is normal in the plants, that some of the guys says, oh, I have my special method to lubricate the machine. First, I have this clean sheet and clean the area, clean the injector, and then adding grease. How many pumps? Oh, the supervisor says that I need to add 350 or 35 grams of grease. Okay, 35 grams of grease. How do you measure that? Well, I exactly don't know, but I put like 20 or 25 pumps into the machine, and I think that is the 35 grams of grease. Some other guys, the supervisor, the manager, because we don't send the technician to take training. We say the supervisor, we send the manager, and they teach them in a classroom a formula to calculate the relubrication intervals, you know, like you were showing that. And the final result is you need to add 35 grams of grease every 3,008 hours. So we go with this instruction to the technician and says, oh, you need to add to the electrical motor 35 grams every 3,008 hours. Oh my God, the technician is in trouble. 3,008 hours, how much is that? And he's trying to calculate. He doesn't know. And I said to the guy, or the supervisor told to the guy, you need to add 35.7 grams of grease. He will convert the grams in pumps. Okay, how many pumps they need to add. So he will divide 35 between 2, because 1 pump equals 2 grams of grease. Okay, the result is 18 plus 2, or 18.2 pumpings. So the technician will go 60, 70, 80.2. We are killing the machine. We are affecting the reliability. We are losing money. And if you go to the general maintenance manager offices, you will see a beautiful, you know, these KPI indicators. telling that everything is good, they have a good maintenance. He's in front of the CEO speaking that, oh, look, take a look at my KPIs. They are really good. Why putting making up to these letters, to this data? Because in reality, in the floor, the one that has the power is the technician. Hear me that. The one that has the power is the technician. So, if we have a well-trained technician, will impact directly to the reliability of our machinery. But if we don't, that technician is killing the machine. Hey, Mohammed, what about this? Oh, no. It's not my responsibility in maintenance to take care about shafts and housing measurement. I need the guy that is working with the lathes, with the machinery. I need that guy to come here and measure the shaft or the housing. Or I go to the shop of this guy with the failure bearing, and I say, hey, listen, that shaft is undersized. You need to machine that in the correct measurement. And the machinist will say to me, okay, I need the bearing that you will install on that machine. No, I take a training, and they say that you don't need the bearing. I need to preserve the bearing in the package until the moment that it is going to be installed. And the machinist says, no. I need the new bearing because I needed to measure the bore, and then I need to measure the shaft and make some magic in order to make the good adjustment. We are killing the machine. Okay, I don't have a machinist in my plan, but I have a really creative guys working on the floor. So when a guy is installing the bearing and is coming loose in the shaft, he will say, okay, I need to put some glue in the bearing to make the adjustment. We don't have the glue. I'm not allowed to say brands, but you already know what brand I'm talking about. So you don't have the glue. So you're going to knurl the shaft. Knurling the shaft. In fact, knurling the shaft is a fancy way to dimple the shaft. It's the same as you grab a chisel and start to hit in your shaft to make the adjustment of your bearings. We are killing it because we don't have procedures, we don't have instructions. On in case, if we have a procedure, the one that is writing the procedure never has been in the floor. Never. Or just taking the manual, the instruction manual for the OEM, making a copy-paste in a sheet with the logo of my company. That's the instruction manual. And sometimes we have a creative engineers. Oh, I have to make the procedure? Yes. 1,000 pages of a procedure. It's not a rocket science, you know. If you give to the technician 1,000 sheets of procedures, the technician won't read that. I mean, I am the one who writes the procedure, and I don't read it because there is too much paper on that. Yes, mounting. As I tell you, my first job, almost 30 years ago, my first job, I was hired for this company, and they say to me, okay, I know that you are an engineer, but you will start from the bottom. You're going to be a mechanic guy. You will be on the floor. And you are a lucky one, because the most experienced mechanical guy that we have in this plant, he will teach you. So, he came this guy, very old in that time, and he says to me, Alejandro, I will teach you nothing with bad words, obscene words. He will say that to me, I will teach you nothing. Walk with me, look, and learn. and that's it. I can tell you this. I learned something from this guy. He was the first one to teach me how to install bearings. You know, I came from Mexico, and in Mexico, most of the people, they practice Catholic religion, you know? And this guy, he says to me, Alejandro, the best way to install a bearing is blessing the bearing. Yeah, blessing the bearing. You will take your hammer and you will hit the bearing up, down, left, right, blessing the bearing. He teach me that. Years after, I went to a bearing manufacturer, a very big one, and they give me a job interview. So the director, the technical director, he asked me, hey, Alejandro, you know how to install bearings? Yes, sir, I know. Okay, let's go to the shop and show me. So I was ready. You know, I was ready to, because I really want this job. So I take the hammer and start blessing the bearing. They almost didn't hire me. I don't know why, maybe they like my profile or whatever, but they hired me. SKF is the name of the company. So I stayed several years working in Mexico and in the Netherlands, learning about the ways of the bearing, how to install in a good manner. Mohammed was talking about induction heaters. You know, this time I went to this mill and I have these technicians. They have an induction heater, but they don't have the temperature proof. And they say to me, oh, we heat our bearings. We know that heating bearings is the good practice. Okay, show me how you heat your bearings if you don't have the temperature proof. I was expecting they to pull out a thermometer or something, but no. They started to heat the bearing, and they use two methods in order to see that the temperature is okay. One, the speedometer. Speed into the bearing. If the bearing squeaks, has the right temperature. And the other method is the coloration or decoloration. They say, look, if the bearing is getting darker, like yourself, like myself, it's already in a good temperature to install in the bearings. And you know, they were very scared because they have the induction heater, like, I don't know, 3 meters away. So they start to waiting for the right temperature. And they were like, okay, and running to the machine and installing. And the bearing gets in the middle, stuck in the middle. Okay, don't worry, we have the hammer. Start to hitting the bearing. Come on, we are killing the bearings. In the morning that I was here in Harvey's, he says, you have to have a big hammer, right? And you know those guys has a very big one to install the bearing. Clean, dry, and fresh. 3 words. It comes to my mind every time that I read lubrication. Clean, dry, and fresh. Cultural transformation. Okay? I don't like to go into one company and I don't like to hear that, oh, we have a poor contamination control, we don't use filtration, we have poor storage, we have oil analysis, we don't know what's that. The cultural transformation that we need is going to rely in technology, in skills, in documents, in procedures. And then we will have precision contamination control. We will use state-of-the-art technology, precision lubrication application technology. Okay? So many plants in Latin America, they still rely in time-based lubrication. And when I speak to them about condition monitoring lubrication, they don't know what is that. Hey, you know, with ultrasound, you can do a better job. You will only put the grease that is required in the bearing. We don't believe that. We don't believe that. That is some kind of magic. We don't like that. Because we don't like to care about the human. So, anyways, this is a quote for one of my favorite books. It was written in the early 50s. And what about that? My machine is working well, and then I have a scheduled preventive maintenance. I stop the machine only for one shift, cleaning, adjustment, whatever you are performing, and after that the machine doesn't run. What do you do? That machine was working well. Maintenance. I did maintenance, preventive maintenance. You know what they say? If it's not broken, don't touch them, right? Yes, alignment. Here, there are some solution providers company. Some of them offers alignment, machinery alignment. But come on, if you go to one plant and you see this monstrosity, please kicking off this company from your company. They don't know what they're doing. This is not a precision maintenance technique. You know, they have a combination of materials, stainless steel, brass, whatever they have. And then, of course, my bearings are failing. What about fasteners? Who cares about fasteners? Hey, come on, a fastener is $1 price. It's very cheap. We have thousands of them in our warehouse. Yeah, but you don't know your fasteners. You don't know about materials. You don't know about tension, about torque. You don't know about that. You know, in so many companies, they have a split pillow block. They mount the bearing, and they need to screw the cap. And comes one big guy, very big one, with a big pipe, you know, putting the pipe in the wrench and tighten up. We are killing the bearings. And we are blaming the lubricant. And then we are hiring lubricant companies that sell me the best lubricant because that split pillow block is getting hot. And then when we go to the warehouse, the lubricant warehouse, they have lubricants so specialized that NASA only uses for an electric motor. See? Of course, condition monitoring. What is the best technology, the best technique to make a condition monitoring program? All of them. All of them. As long they work together. Sometimes you go to the condition monitoring office and you see people looking at the walls, and this is the vibration guy, and he doesn't speak with the ultrasound guy, and he doesn't speak with the oil analysis guy. In fact, they are fighting because the ultrasound guy says, okay, don't add too much grease to the bearing. And the vibration guy says, you need to add grease to the bearing. You know, they are fighting. They need to work together to have the best information in order to take actions. Yeah? So, ISO 15243, yes, is the ISO that tells us what are the failure modes in a bearing, okay? Of course, it's important to know this. But most important is to implement the task in order to solve the problem. So many RCAs, the people start to discussing about what was the issue, what happened. I have the electrical manager, I have the mechanical manager, I have the condition monitoring manager, I have the superintendent of the plant, and they are discussing about the failure. Excuse me, but sometimes they don't know what was the real problem. Is going to win the one who speaks louder or the one who has the highest position in the organization. And most of the times, this RCA will finish with a preventive maintenance task. Okay, we know that the bearing was the problem. The solution, replace the bearing every 6 months. We don't go further. And we don't go further because the bearing, the body, the dead body, is already in the trash. Nobody takes a look of the bearing, of the failure bearing. No one. No one. And we are doing RCAs. No? So, in order to connect in an effectively manner the mold causes, or the mold causes with the root causes, we need to inspect, or we need to discover, or we need to find the failure mechanism. What was printed in the failure bearing. We need to take a look of the bearing. How does it look? How does it smell? Yes. We need to touch the bearing. And yes, most of the times I read RCAs documents in some companies that they mix concepts. They mix failure modes, they mix root cause failures. And they mix the failure mechanism. So, I will not go further in this chart, which is important, but rather than that, I will show you how we can apply this, okay? So, there is a cement company, okay, a cement company. It has a kiln, very critical machine for a cement company, and this kiln shut down 3 times per year. That's very bad, really, really bad for a cement company. Because the kiln, you know, works in a high temperature. So if I shut out the kiln, it will lower the temperature. In order to start again, to gain the right temperature, it takes days. Sometimes it takes days to have the good temperature. So, stopping 3 times a year, it was impacting very hard for the business of this cement company. Effects of the failure. As I tell you, engineers don't like or don't know how to talk in money language. They only care that, oh, we stopped the kiln, we need to make the correct actions to run it again. But if we read underlines what was the effect of stopping this kiln 3 times a year, you can see these numbers. They perform an RCA, and the solution was to have a redundant system. They only have one motor, because the problem they found was the bearing on the electric motors. So they say, okay, we don't want to happen again, so we're going to invest, we're going to execute CapEx, and we will have a new motor, a redundant system. So if one bearing, one electric motor fails, we don't worry because we have the other one. More than almost 150,000 US dollars cost the solution of that problem. 150,000 US dollars. You know, a problem has many different solutions. Our job as a forensic engineers, as a bearing failure analyst, is to find the best cost-benefit solution. People in the cement plant was very happy because they stopped, they solved the problem. But when this number went to the big office, to the corporative offices, someone read that number and says, hey, what happened here? Why we invest 150,000 US dollars to solve that problem? What was the problem? So we start to making the analyst using the ISO standard. And we need to take the bearings from the electrical motors. We need to inspect, we need to cut the bearings because we need to observe the raceways, the cage, the bolts, okay? And we find out that bearings, so the bearing failures, are three failure modes. They have wear, corrosion, and electric erosion, okay? That's the first part. We already know what are the failure modes. And this is the evidence, okay, for every failure mode. This is the failure mechanism you need to observe, okay? We have adhesive wear, we have frictional corrosion, and we have fluting, electrical fluting. That's our failure modes. We already know what was happening in the machine. Okay, but the job is not finished yet. We need to develop the task, the maintenance tasks, in order to avoid this. So, now, after we analyze the failure modes, we will have our root cause hypothesis for failure modes. In this part, we need engineers, we need technicians, please, we need technicians to brainstorm about what was happening, what was the problem. Okay? No matter how impossible is the root cause, no matter if it's very easy or whatever, you need to put all the probable root causes of that failure. So in that time, we have current leakage failure, we have preload failure, we have a fits and tolerance failure, and maybe inadequate lubricant failure. We have 7 failure mechanisms linked to the failure modes that I already observed. Now this is the time to do calculations, to do engineering stuff, okay? Because yes, if you are an engineer and if you have this kind of problems, you need to make engineers think. You need to make calculations. And I don't know in your countries, but in Latin America, it's very common that engineers, when they go out of the school, they never took a book again. They never read a book again. They don't do math. They don't do calculations. They like to solve, or they are trying to solve everything, speaking with older guys. Hey, happens to you that failure before? Oh, yeah, it happens. The root cause is the bearing brand. I already tell to the people that don't buy this bearing brand. You need to buy this one. And engineers are writing that solution. The solution is changing the brand of the bearing. So, in this part, we need to make calculation, we need to use solution. I don't see Mark here, right? Oh, thank God, because he will kill me if I show this solution. But, I mean, in that time, that was we have at hand. So we use this solution for the current leakage. Most of the guys will tell you, oh, if you have current leakage, you need to put insulated bearings to solve that. And it's not like that. You need to use more components, more solutions. So, yes, you need to use bearings, insulated bearings, or ceramic bearings, or hybrid bearings, whatever you have at hand. You need to use the famous rings that Mark doesn't like. You need to use colloidal silver when the rings are touching the shaft, to improve the conductivity. And also you need to use your ground strap. This is very important, very important. If you walk the plant, if you walk to one mill, you will see a lot of electrical motors with the ground strap disconnected. That is killing your bearings. 4-part solution: bearing, rings, colloidal silver, and ground straps to solve the current leakage problem. Hey, the preload. Do I have any electrician here? No? Any electrician? Well, if you go to the electrical department, the guys that are in charge of the electrical motors, They don't know about the preload. They don't know the springs. They don't know the spring washers. They took out the spring washer in electrical motor, and they see a component that is wavy, and they have a hammer and start to straighten up that spring washer. And it's very easy to calculate the preload we need. It's all in the books. Every single bearing manufacturer has a general catalog. And you need to read the technical information, and you will find this kind of stuff. You only have to do a multiplication. A factor K, which is dependent of the size of the bearing or the operating condition, and the small d, the inner diameter of your bearing. Make a multiplication, and the result will give you the preload that you need. Very easy. It's not rocket science again. Shaft housing fits. Hey, I will measure the shaft with my special tool. It's a vernier. This is a precision component, so we need to use a precision tools. Vernier is not going to give you the precision that you are looking for. In fact, some of micrometers, they don't have the precision that you are looking for. And it's an expensive tool, of course. But I mean, I like to invest in a precision micrometer rather than have an electrical motor failure. And of course, I need humans, I need the people to know how to use a micrometer. For the young people, now we are in the digital era. So you need the micrometer with the panel, with the screen to tell you the measure. Come on. I'm pretty sure that in the plants, we have old people or well-educated people that know how to read the scales. You don't need to hire for a course or for a metrology training to invest in expensive training. Grab one of these guys and ask him to teach your staff. Reliability, common sense. Huh? Thank God. For this case, based on evidence, it is concluded that for this event, lubricant failure is an effect, not a cause of failure. An effect. How many times we blame the lubricant, or we think that lubricant is the reason for the failure? Most of the times. Because there is this statistic from the 60s, 70s, 80s that is telling us that most of the bearings will fail because of lubricant. And a lot of people is reading in a bad way that information. They are thinking that lubricant has the responsibility for all the failures in my plant. And it's not. Lubricant is not guilty, until you prove the different. Okay? Don't blame your lubricant. The last part of this analysis, okay? We need to link the root causes to the failure modes and defects that are provoking. And this is the most important, because from here, from this chart, you will extract maintenance tasks. And those maintenance tasks, they need to go to the floor. They need to impact to the floor. If not, your job doesn't work. Hey, I'm a forensic engineer. I made the bearing failure analysis. And what happened with the company? I don't know. They don't call me anymore. I just made this project. And the company still has the problem. And they call another company, they call another guy that actually push to implement the solutions. We need to push to implement the solution. If not, our work is not complete. And this is the bad part of RCAs or FMEAs. Most of the consultants, most of the engineers that we are working in this area, we stop here or one step behind. We are not doing following up to see if the instructions are made to the ground. We are not investigate if they are follow my recommendations. Because if they follow the recommendations, will impact into your reliability. This was in 2019, before COVID. I called to this customer, and he says to me that there have been no shutdowns in the kiln, at least not to do it to the electrical motor. There has been no bearing replacement on electric motor. COMO values, condition monitoring values, have remained stable in electrical motors. And you know what? The solution was only replacing 8 springs, 8 small springs. Let me go back. Here. Tell me a number. How much do you think it cost 8 springs? How much do you think is the cost? Less than $10, less than 10 euros, maybe? 1 euro, 2 euro. And the people in the cement plant, they solved the problem with 150,000 US dollars. Cost benefit, cost benefit. Okay? And again, cultural transformation, work with people, the people that is in the ground, the one that has the hammer and the chisel. I still like those guys to have a hammer, of course, but they need to know how and when to use that hammer. No blessing the bearings anymore. Proper tools. And then, this comes to this end, training. Training, training. I'm glad that most of the times now that I go to this company, they have human resources, but they have a satellite department working with the development of the staff. They need to know if they need to upskilling, okay, to improve the experience, the skill they already have, or if they need reskilling, upskilling, learn new things. This is very important. If you want reliability, take a look of this. Yeah? Let's finish up. So, my men, quiz time. So, take out your cell phones. Take out your cell phones. You will need it. You will need your cell phones. We're going to make this very quick. I have a quiz. Does anybody knows Kahoot? No? It's an online platform to make a quiz. So we will make one. It's very easy. So, let me, okay. So I need you to go to your cell phone and to look for Kahoot. Just type Kahoot. You need to look for Kahoot. Press when there is begins. What says begins? Here. Oh, what is it? Again? Yeah. Oh, I don't know what's happened. Maybe it's a pop-up window. Yeah, you need to unblock. I don't know if you have a... Yeah. Okay, go to kahoot.it and it will ask you for a PIN number. No? Oh, yeah. I have it. I have it on my backpack. Well, yeah. So it will not show, right? So I'm sorry. The computer has a pop-up window that closes down the collection, but I just was about to do the first World Championship of Bearing and Power Transmission Forum. So it was a quiz with 10 questions. Then you need to answer the faster as you can, and we will have a winner, and the winner, we will name it the world champion of this forum, but I think there is the problem, right? So go back to my slides, to my final slides. Yeah, so it was an honor to be in front of you guys. Thank you very much for your attention. That was displayed my phone number and email, and maybe I'll see you in another time. Thank you.